tomorrow electronics. Okay. So what is now isotope effect?
The next chapter which will start?
Electronics.
Okay, sir.
Isotope effect. Now, do you understand what you mean by isotope? Isotope क्या होता है? What is isotopes? So if we have two more than one, so we have isotope means the elements which have same number of Z. Okay. So if you have more than one isotopes, okay, so then isotope effect says that the transition temperature of isotopes, okay, so transition temperature of isotopes is proportional to their mass power alpha, okay, that power minus alpha. And in general we write this Tc m power alpha equals to constant, and alpha value generally taken as a half, so we can write Tc m power half equals to constant. Okay, that is, if you take, suppose you take two isotopes, okay, which have a different masses, okay, some superconducting material which have a Tc, so two, if there is a difference of mass, okay, then their critical transition temperature, that will also vary by this equation. Okay, for example, if I say mercury, so mercury one isotope has the mass 202, and this is the transition temperature Tc1 equals to 4.159 Kelvin. Okay, now if I take some other isotope, okay, of mercury whose mass is 200.7 Kelvin, okay, then what is its Tc? Find out, calculate what is the Tc. So you can use this equation, okay, and you can find what is your Tc. Okay, so you can write Tc1 m1 half equals to Tc2 m2 half. Okay, if you want Tc2, that will be Tc1 into m1 upon m2 power half, and particular question they given 4.159 Kelvin, and m1 is your m1 is your, see this is m1 or m, you can write also m, so 202, okay, and this is your 200.7, okay, and if you solve this one, I have the answer 4.172 Kelvin. Okay. Just check it whether it's coming or not. So slightly higher. Okay, so mass is higher, so transition temperature is higher. This is a less mass, so this transition temperature also slightly lower. So transition temperature varies with mass. Okay, this is called your isotope.
How we will say alpha equals to half, sir?
This is experimentally observed fact. Okay, this relation varies. So alpha generally is equal to half. The variation, if you measure experimentally, is comes out half.
And Tc varies with mass, na sir?
Tc varies with mass of isotopes. Okay. Now let us do some exam problems. So yesterday we have seen that, so the question is there, a Josephson junction consists of two superconductors separated by a very thin insulating layer. Okay, when a DC voltage is applied across the junction, an AC current is produced, and this phenomena called Josephson effect. You're asking calculate the frequency of AC current produced when DC voltage is 1.5 microvolt. Okay, so a Josephson junction, they are applying So when they applying
Can you
1.5,
repeat the question once again?
so
Question.
we have a Josephson junction, okay, and across the junction we are applying this voltage 1.5 microvolt, okay. So you're asking the calculate the frequency of AC current produced. Calculate the frequency of AC current produced. So what is the formula? What is the formula?
What? 2 into E into V by H.
2 EV by
H.
H. Okay. Put the value, just calculate. How much is coming? What is the answer? 7.2 something. This is your
7.7 into 10 to the power 8.
10 to 7.2. What I have answer 7.253. You can check. Okay. Slightly there may be change. So I have the answer. So also you can calculate what is the value. You can put the value. You can find. So this is they ask frequency. If you angular frequency, then you have to. Then the formula is slightly changed. You know.
Sir, 7.253.
And 10 to the power 8. Okay. Now they are given you. They are asking calculate the wavelength of photon which will require to break a Cooper pair. Okay. They are asking what is the wavelength? What is the wavelength? They are asking. Okay. To break Cooper pair. Cooper pair. Okay. You can also write T is at T is equal to 0 Kelvin. At T is equal to 0 Kelvin. Okay. Now, yesterday you've seen, and they also given you the transition temperature, okay, of aluminium. So calculate the wavelength of photon which will break required to break a Cooper pair. Okay, for aluminium, they given you transition temperature also, aluminium, and they say that is equals to 1.2 Kelvin. Okay, so what is the formula we will use? Cooper pair energy is equal to what? Cooper pair energy is equal to
Equal to 2 delta.
2 delta. Very good, band gap. So Cooper pair energy is equal to 2 delta. Okay, and which is equals to what? 3.5 kbTC at T is equal to 0 Kelvin. KB is, you know, TC is given. Okay, so you can find the band gap, and once you know the band gap, you can write SC by lambda 3.5 kb TC. You want wavelength, so wavelength will come SC by 3.5 kb TC. Okay, and you can solve this one, and you can tell me what is the answer.
Sir, 3.5 kbtc is given, or we take
This is a formula for band gap, right? T is equal to 0. Band gap EG is equals to what? T is equal to 0. This formula is there, and this is equal to Cooper pair energy.
yes, sir.
Okay. So lambda, you can put the values. Okay, you know everything. You can calculate. I'm writing the answer. Okay, you can tally that one. So answer what I have. Okay, that is 3.4 into 10 raised to power minus 3. Okay. So let us solve some other problems. So is GATE 2014. Okay. Question number 6. GATE 2014. So this is which of the plot is correct for superconductor. Okay. So see, they given the graph of CP versus temperature. Okay. They given this graph like this. The option B is CP and CB are same for solids. Okay, almost CP. So they given you this type of graph, and this is a transition temperature TC, and then you have this transition temperature. This is your TC, CP, and the option D is okay. So which is correct?
C.
C is correct. Huh? So yesterday what we have seen, which quantity has a discontinuity? Which quantity has a discontinuity? Is a discontinuity
Equal to TC.
TC. Sorry, 1 minute. One more thing. I have to correct this one. Okay. So you saying this is a B and C is this one. You're saying this is so about TC. It varies like a linear.
That would be A. That is exponential kind of value.
Yes, this is exponential. This is A option, and there is a discontinuity here. Okay, and then it is a normal. That is the normal state. So it's not proportional to T here. Okay, and it's not a straight line letter. Okay, then it's like this. Okay, so this is the option is A is correct.
Yesterday you drawn two curves, one straight line and one is.
And so that is a normal state. Okay, superconductor. This was superconductor, na? Exponential decreasing and then discontinuity. Here's the discontinuity, na? Suddenly discontinuity. Your CP is very high. The conductivity of superconductor is very high at transition temperature. This is not transition temperature. Actually, they have drawn wrongly. This is your transition temperature TC. So at transition temperature, you have discontinuity. That's why
Yes.
we call it. This is second order transition. Okay. So this is the with temperature it is second order, and with magnetic field it is first order transition. So now there's one more question from this GATE same 2018. GATE 2018. Okay. Among which of the quantities will show sharp change at the TC? Okay, this basically I'm asking for type 1 superconductor. So they have given you some quantity. This is resistivity, this is thermal conductivity, this is the specific heat, and this is the Young modulus. Okay, and option second is resistivity, specific heat, and susceptibility. Option C is rho, K, C, and X, and option D is your K, thermal conductivity, Young modulus, and chi. Okay, so which option is show sudden change near transition temperature? Which group of pair of properties change at transition temperature? Okay, tell me which is the answer. So this is the resistivity.
Sir, can you say the question?
So which of these following quantities show sharp change at
C.
TC? TC.
C, sir.
C क्यों? ये थर्मल कंडक्टिविटी मैंने कहाँ बताया? शार्प चेंज कहाँ बताया? थर्मल कंडक्टिविटी. resistivity चेंज होता है, specific heat चेंज होता ही है. Okay, resistivity becomes suddenly 0. This shows discontinuity, and this chi becomes diamagnetic, perfect diamagnetic. So this becomes -1 and then 0. Okay, this chi suddenly changes as superconducting state from -1 to 0. So the B option is correct. Okay. Now you write some formulas. Okay. You know the penetration depth lambda is given by m upon mu naught ns and then e square. This is the formula for penetration depth. So a question they're asking for niobium. Okay, you have a niobium, which is superconductor. Okay, its atomic density is given 8.57 into 10 raised to the power 3 kg per meter cube. This is the atomic density, sorry, mass density. So mass density given, and they say each atom gives one electron. Okay, each atom gives one electron. Okay, basically जितने atoms है उतने electrons है. Okay, and they says the atomic number is 93. Atomic number. Okay, atomic number को कैसे लिखते हैं? Atomic number. How do you write atomic number?
Z is equal.
This is a jet. Atomic number say. Atomic number is Z is 93. Or better to write this in, you say atomic number. I will write atomic mass. Okay, not number. Atomic mass is given 93. So they're asking what is the penetration depth. Okay, so how can you write this is the mass of electron? Okay, this is the mass of electron. This is mu naught, you know, constant, you know, E is constant, you know, you want to know the density, super electron density. What is the super electron density? Okay, so super electron density will be same like what? It will be like a atomic density, because each atom is giving one electron. Okay, so you need to find basically what is the atomic density. Okay, so mass density they are given. Okay, so if I want to write atomic density, so how can I write? So suppose I want to write number of moles, and so this is what? This is equal to number of moles, yes or no? This is Avogadro number, is total particle. Total particle you divide by Avogadro number, जो भी ratio आएगा, that will be number of moles, yes or no? It is equal to number of mole.
Yes, sir.
Yes, okay. And this will be equal to same like m upon ma, mass of the substance divided by molecular or atomic mass. That will give you again molar number. This is the relation between this is moles. Okay, so I want to find n, number density. So n will be what? M will be your m na upon ma. Okay, now I want the number density. So these are the number of atoms. Suppose this is the number of atoms. Okay, yeah, this is suppose n number of mass of n number of atom. This is the mass of n number of atoms. Okay, so this you get this number of atom. Now number of atom, this is atomic density, which is here equal to super electron density, because each atom is giving one electron. So this becomes your ns. So ns will be what? Ns will be your m na v upon ma. Okay, now this is the mass of the sample of an atom and this volume. So this gives you density. So this is rho na upon ma. Okay, so from here you can find the ns, you can put here and you can calculate your answer. Okay, so put the values in this formula, that is 9.1 into 10 raised to power minus 31 kg. Okay, then mu naught is what? 4 pi into 10 raised to power minus 7. ns you can find it from here. Okay, e square, you know what is 1.6 into 10 raised to power minus 19 square, and ns value you can calculate. Put the values, rho you know, na you know. Okay, this kg, so you have to put accordingly 6.02 into 10 to the power 26. Okay, and atomic mass is given ma to you. So if you solve this one, I have the answer. You can verify. It will come to 25.7x76 angstrom. Okay. Now you have been given critical magnetic field SC at 4 Kelvin is equals to 11 milliampere per meter. Okay. And SC also given at 8 Kelvin, that is equals to 5.5 milliampere per meter. Okay. He asking find TC. कैसे निकालोगे TC? So what is SCT is equals to what?
H naught
H naught or SC0? H naught or SC0?
1 minus T by TC whole
by
to the
TC,
power
T by
T
TC
by TC whole to the power 1 by 2.
square power 1 by 2, na? Okay. So this is the formula. Put the value, tell me the answer. So you can write SC value at different temperature and can divide. Okay. And you can find what is TC. I'm writing the answer here. TC is 10.5 Kelvin. Okay. So you can do it at a calculation only. Okay. We have a small class today. So I just want to solve one more problem, similar kind of problem. Okay. So this calculation, you can note down the answer. So they have given you similar kind of problem. Now they say T is equal to 3 Kelvin. The penetration depth is given 396 angstrom. 396 angstrom. Okay. And penetration depth at T is equal to 7.1 Kelvin is given as a 1730 angstrom. Okay. So they're asking what is the value of TC. So the formula for this one is slightly changed. Okay. If you have been given lambda LT, that will be same like lambda at T is equal to 0. Okay. And 1 minus here this is changed. This is TC power 4 and this is minus half. Okay. And put the values and calculate TC. So if you solve this one, putting these things, TC value should come 7 point, this is your homework, 7.93 Kelvin. Now if you do the problems of previous year, okay, so I can see this all problems are direct, they are just asked direct problems. Okay, I don't find any problem you find difficulty. All the questions are very simple. You just try this previous year questions. Okay. If you have any doubt, send me. So I think this chapter is finished. Okay. And
Sir,
now,
after this chapter, which chapter will you start, sir?
now tomorrow I'm starting this electronics network analysis. Okay.
Okay, sir.
So I'm stopping here. So this time we'll focus.
Sir,
Huh?
semiconductor.
Huh?
Semiconductor.
Semiconductor after network analysis.
Okay, sir.
Before the diode. Okay.
Okay, sir.
So this time I'm thinking to focus more on this capacitor and inductors. Okay. Because resistors, dealing resistor type of networks is easy. Okay. So I'll do some more problems on capacitor because I find that students are facing problem whenever there is a capacitor in the circuit or inductor in the circuit, they are not able to deal. Okay. So those problems we'll do more this time. Okay. So thank you. I'm stopping here.
Thank you, sir.